Okay, so we're in the last part of time series. So if you remember, we had a time series. So we were looking at something, so we'll have a response variable, and then we'll have our time code or whatever time thing along our EV. So once we might have our time series, or we might even have our deseasonalized data as well. So what we're going to do now is we're going to get the equation of that time series, and we do it exactly the same as our scatter plots and our linear regressions. So if you look here in this data down here, we've got the table below shows the number of female students in Victoria enrolled in at least one math subject learning area in Year 12 over the period of 2010 to 2018. And it says fit a trend line to this data. So this is a case where they have used the actual year as their numerical value for the EV. So this one is their EV, and it's pretty much their time code has actually been the year. Okay, they've actually used the year number. All right, year number. And then this is our response variable. So when you go and pop this into your calculator to get the trend line, so if you want to write up here, the trend line is the least squares regression line, yeah? It's the same way we're doing it, the least squares regression line. Okay, so when we pop this into our data, into our calc, and we do that least squares, and I'll just write a plus bx. When we get there, our x list will be the year, and our y list is going to be the number of females or whatever. Okay, so they've popped that in, and you can see down here, and I've already drawn there, they've written our a value, which is there, it's a negative a value, and they've got your b value, which is the slope. And that's there. So now we have a trend line. So this is the trend line. So in a time series, the least squares regression line is called the trend line. Okay? So we've got that here. So when we are predicting using the trend line, that's called forecasting. So it's all the same. We're just using different words, okay? So using a trend line fitted to a time series plot to make predictions about the future value is known as forecasting. So really, we're going to predict outside of what we've seen. So we're actually extrapolating, aren't we? Yeah? So these ones are extrapolating. We're forecasting that this is going to carry on the same. But anyway, so it says down here, how many students in Victoria do we predict to be enrolled in the maths subject in Year 12 in 2026. So there's the time code, and they won't give it to the whole number. So I've got to predict or forecast. All I have to do is use that formula which they've given me. I've reprinted it there. So number of females equals, and then I've popped this into my calculator, plus 851.017, and I'm going to times, and it says the year. So they're giving it away anyway. They showed that a year was a year, so I just put 2026 in there, and I end up with 90,580 female students predicted. So I rounded to the nearest whole number. Make sure you're reading all that. You're not going to get a mark. There's no half marks. You just lose it. Okay, so forecasting taking seasonality into account, that's just when, instead of using the original data, we're going to use the deseasonalized data. So do you remember when we did the set of deseasonalizing, and we deseasonalized every value, and we could then redraw our time series with that deseasonalized data? That's all we're going to do. So here, what they've done is, though they've got the data for, it was 3 years. So let's just be careful here. this was quarterly, and so there's year 1, there's year 2, and here's year 3. Okay, so the quarter 1 in the first year equals 1, and then quarter 1 in third year actually equals 9. So there's the time code. So they're putting that time code in there. They're just listing the quarters as it happened. So that's why, because we've got 3 years, we've got 12 quarters listed there. So what they're saying is that they have already deseasonalized. So these values here, all along there, they are the deseasonalized values. So they already went and did it all, and they deseasonalized it. So what we're going to do is we're still going to get the forecast, we're going to get the trend line, except we're going to use the deseasonalized values. So we're still going to do a linreg and the A plus BX. You'd still do that. The X list will be your time code, and your Y list will be your deseasonalized values. So they've just written it out as sales equals, and they've put the equation there. I would like you to write deseasonalized sales above that, because in the exams, and you'll see in a minute, they always write the deseasonalized sales. They're letting you know that that was actually a trend line using the deseasonalized values. So it should have been written like that, deseasonalized values. So this is your A and that's your B. Okay, so we still do the same. So what sales do we predict Mickey's shop in the winter of year 4? So if you look at winter, say, I'm assuming we're saying summer, autumn, winter, spring. Summer, autumn, winter, spring. So if you keep following that pattern, winter in year 4 is going to equal a time code of 15. 15 will be the time code. Yeah, it'll be the 15th quarter of this data. So we're going to predict. So we're going to use that formula. So we're going to say the deseasonalized sales, and I'm just going to use that formula. So 838.0 plus 32.07 times, it's 15 because it's the time code, and it says what sales. So I'm going to go to the nearest whole number because that would make sense, wouldn't it? I'm not going to have point something of a sale. You either make the sale or you don't make the sale. So I'm going to write to the nearest whole number so I get that. Okay, so a number of visitors at a regional animal park is seasonal. The data was collected and deseasonalized before the least squares line was fitted. So can you see, they're telling me now, see how I told you? They will tell you when it's an equation for the deseasonalized value. So there's my A, there's my B, and so on. Now, oh, it'll catch up. So they're telling me here the month number 1 is January in 2020. So that's a time code. So you've got to be careful. They've given you a time code there, so we've got to be wary of that. And obviously the seasonal indices for all the months are given there. And then it says down there, it says the actual number of visitors predicted for February in 2020. So obviously we were talking about deseasonalized data, and when they're asking for the actual, remember that we've got this reseasonalizing data, which is a way to get the actual. So if you look there, I'll just write this out here because you don't have that. I've grabbed that formula for you to show you. So if you remember, actual we found by using the deseasonalized times the seasonal index. So I want February 2020. So I get February's seasonal index. So February is month 2. So I have the seasonal index. But how am I going to get the deseasonalized value? I use this formula up here because this is a formula to get a deseasonalized value. So what I do is I use that formula, 2349 minus 198.5, and then I have to times it by the month number. So February is month 2 in 2020. So I do times 2. Sorry, get that. Oh, he won't get out of the way. So then I have to, that was the deseasonalized value, and then I times it by the seasonal index, which is 1.25. Okay, so this seasonal index is that number there. This DS was, I used the formula up here. Okay, and then we get a value, and I get it to be 2440. So that's how I found that one. Alright, so the table below shows the monthly rainfall in 2019 in millimetres and recorded at a weather station, and the associated long-term seasonal indices for each month of the year. So we've got all the what we call, this is the actual data, and here is the seasonal index. Okay, so the deseasonalized rainfall for May. So this is where you simply, if they're asking the deseasonalized, just go and write the formula. So I'd be like, all right, deseasonalized is actual over seasonal index. And as soon as I see that, I go, okay, May 92, there you go. Actually that, the seasonal index is 1.222 and it equals 75.8. So that was a nice easy one. Just look at what they're asking, write the formula for that, and then everything, then go find what you need, which you should be given. Okay, the next one. So the table shows the seasonal indices for Millville Animal Sanctuary for quarters 1, 2, and 3, and 4. Now it says complete the table, calculate the seasonal index for quarter 3. We have no other data except for that. So all I know is if I add these up, they should equal 4 because I have 4 seasons. So when I go to find what the missing one is, I'm just going to say 4 minus the other 3 added up. And we end up with, 0.6. So we pop it in the table because that's what they asked. In 2019, the total of 43,516 people attended the sanctuary. So as soon as I know that they are telling me what actually happened. So there's an actual, and they said for quarter 2, determine the deseasonalized value. So I grab that little formula again. So DS is actual over seasonal index. So they gave me the actual in the question, and I need the seasonal index for quarter 2, which is up there, 1.1. And I do that and I get 39,560. Okay, so it can come a lot easier if you just write the formula and then go looking for what you need. So in part C, the trend line was fitted to the deseasonalized value. So I told you they write it as a deseasonalized. They put deseasonalized in front of it. Okay, and use this trend line to predict an actual. So when we want an actual, that means we're reseasonalizing the data. So when we do that, actual is the deseasonalized times the seasonal index. So I'm going to use that formula again to find the deseasonalized value. So I would use 61860 minus 9748. Now I have to times the quarter number. So I go back up here, it said set of quarterly attendance 2019. So quarter 4 in 2019, so it is just quarter 4. and then I times it by Q4's seasonal index, which up there I can read is 0.8. And then we do that and we get 18,294. So analysing sales, the golf shop owner fits a least squares line to the deseasonalised value. So deseasonalised sales are there, where T1 is the summer for 2017 and T2 is autumn 2017. So this is quarters. And the seasonal index for winter, so they've told me a little bit of information there. Now, it says use the equation of the trend line to predict the actual sales. So that's why I have the reseasonalizing data. So when we want to find the actual, we're reseasonalizing, so we want the deseasonalized times the seasonal index. So if you look up here, we need to work out what time code winter 2019 is. If you think about it, T3 is winter 2017, T7 is winter 2018, and what T11 will be winter 19. So I'm just adding 4, makes it quick. That's what I did to make sure. So I know this one's T equals 11. So when I go to use that deseasonalized equation, I know I've got to type in the right quarter. So this is quarter 11 there, and then times the seasonal index, which they gave me. All right, so I get 55.9, but it says up here to go to the nearest whole number. So I'm going to say that equals 56. All right. And when we go through our exams, we check our highlighted and we can check our whole number. Done.